Okay. All right. So first thing you guys said that the this is a review form for review for test on test chapter on gases and on solutions and reaction rates. Solutions and equilibrium, reaction rates. Okay, so we will cover very, very important questions. So now, remember that number one. So we will first cover the solutions because that one obviously has a lot of information. So let's see all the important things that are going to be on the test. And yes, other things, of course, you have to do. So first thing from the solutions chapter is that the first part is about the solubility. Okay, the solubility of ionic compounds. So let's look at that. So here for the solubility of ionic compounds, what are you going to do? You are going to look for the table, right? And now you guys tell me, since we are doing a review, what table are we using here? On where is that table in the handouts? Table in the handout, what page is that? Page 8. Okay, and what's is it a table number? Okay, anyways, so let's do some of the questions here. I'm giving you this, let's say FeSO4. Okay, tell whether they are soluble or insoluble. Na3PO4. Okay, ZnNO3 whole twice. Okay, next is calcium CaCl2, NH4OH. Okay, then BaOH whole twice, something like this. Okay, so now you guys tell me based on these, which one is soluble and which ones are insoluble. So remember that for the soluble, what are we going to write? The solubles are AQ, soluble in water, and insoluble would be, insoluble is S. So insoluble is S. So don't forget that piece first. Insoluble is S. Okay, now tell me. FeSO4, soluble or insoluble? Yeah. No, I'm going to share it. That's why I'm recording it also. Yeah. Soluble. So here we have this soluble. FeSO4. Why is it soluble? Because the rule is sulfates are soluble. Okay. So when we say this, now another thing is, so now let's just do this thing that. Okay. So now the thing is, if it is soluble, so what are the ions that are going to be formed? What ions are formed? So this is soluble. So, this is soluble. So it is S, or sorry, AQ. So what are the ions that are formed here? How does it ionize? So the best way to get this is, what are you going to do with the FeSO4? You look at sulfate, right? SO4. SO4. What are the charges on sulfate? -2. -2. That now let's say if you don't, that's what I was asking you. You have to memorize the polyatomic ions and the general ions, the names of the elements, symbols of the elements, all this has to be memorized. But just in case you forget whether it was -2 or -1, I mean, ideally you should remember if you practice it, but not, you can consult the handout. So here you have SO4 -2. So what is the charge on Fe based on this? +2. That is why you don't see, you see this is sulfate is SO4, but then it's not like sulfate is in a bracket. So that means these +2 and -2 charges are canceling out. So +2 charge, -2 charge cancel out. That's how you get this guy. What about the next one? Na3PO4 whole twice. Soluble. So why is it soluble? Na, right? Very easy to remember. Na, Group 1A, soluble. Okay, how are they going to ionize? How many sodium ions are formed here? 3, very good. So 3 sodium ions. What's the charge on sodium? Group 1A, +1, very good. And for the phosphate, what's the charge? Remember that crisscross? -3. So this is coming from this, okay? PO4 -3. So now this is how they are going to ionize if they are going to be soluble in water. What about zinc nitrate? Soluble. So what are the charges? Why is it soluble now? NO3. So you see, our identifying things are like here, nitrates. All nitrates are soluble in water, just like all sulfates are soluble. And then you have to just check for the exceptions. In this case, the identifier is like sodium. All sodium ions are like sodium. Anytime it attaches to any polyatomic ion is going to make it soluble. Okay, zinc nitrate. Zinc nitrate. Soluble, right? But for charges, how many zincs are there? 1 zinc. And what's the charge on zinc? +2. Remember that this 2, don't forget that this 2 is coming from, this particular 2 is coming from on top of zinc. So this is zinc +2, and this is 2 NO3 -1. Okay. And this is, so all of them are, this is how they dissolve in water. So zinc has got +2. It needs 2 nitrates to cancel out those +2 charges. You get that? Okay, good. What about calcium chloride? Soluble in water? Okay, see, all chlorides are soluble in water except what? Say that again. Except which one? Lead, silver, and Hg mercury, right? So that means this is going to be soluble in water. Sorry. And soluble in water, right? And so here, what do you get then? Ca +2 and 2Cl -1. So these are soluble in water. That means this is also AQ. What about NH4OH? Remember NH4. NH4, wherever NH4 is, it is soluble in water. So what do you get here? This is NH4 +1. And what is this? OH -1. Okay. Okay. So these is +1 and -1 cancel out. So that, but ammonium, identifier is ammonium. So anytime ammonium is there, it is soluble in water. So you will have to practice it. What about barium hydroxide? Soluble. So this is soluble AQ. Okay. And so here you have 1 barium. This will ionize. And this is the 2 OH ions. These are -1. They are not going to ionize. This will ionize like this. But so these are ionic compounds. So you will refer to that table. Now let's do a few more here. Let's say, okay, I'm going to change it. Let's say I'm asking you, write down the formula for calcium phosphate and tell whether this is soluble in water or not. See, writing the names, formulas, this is all continuous thing. Calcium phosphate. Okay. And then magnesium sulfide. Okay. And then comes copper 2 carbonate. And then this one is lead 4 chlorate. Lead 4 chlorate. Yeah. Do you have that chlorate in your note on that? Is chlorate there? Sometimes it's not there. on the table? Or just do chloride. Let's do it chloride. Let 4 chloride. Okay, let's write down the formulas of these guys. Let's write the formula of this. Calcium phosphate. What's the symbol for calcium? Ca plus 2, group 2A, and phosphate minus 3. Very good. So what do you do now? Crisscross. This number comes here and this number is going to go there because it's more than 1. So phosphate goes in bracket. So now what is the formula? This is Ca, what? 3 brackets, PO4 whole 2. So this is soluble in or insoluble. What do you think? Insoluble. All phosphates, right, are insoluble except group 1A, and calcium phosphate is, calcium is not a group 1A. Magnesium sulfide. Okay, let's write down the formula for magnesium sulfide. Formula for magnesium, Mg, and sulfide formula, S, right? Charge on magnesium, charge on is sulfide, -2. Sulfide is -2. Crisscross, what do you get? This number comes here and this number come here. +2 and -2 cancel each other out. What do you get? MgS. All right. So soluble or insoluble? All sulfides are insoluble. So what do you get? That means it is going to be like a solid. Okay. Okay. Next, copper 2 carbonate. Copper, Cu, charge, +2. Carbonate, CO3 -2, right? So now, same story, crisscross. This number comes here and this number comes here. What do you get? CuCO3. Soluble or insoluble? Insoluble. All carbonates are insoluble except group 1A and ammonium. Okay, next, lead 4 chloride. Lead, Pb, charge, +4. Chloride, charge, -1. Crisscross, this number comes here and this number comes here. What do you get? PbCl4 and solid. Okay, solid. All right, so this is the solubility of the ionic compound. So these type of questions will be there. Now, next thing is, if you are given another type of question, which is based on the, this is the solubility of ionic compounds. And then let's look at the solubility of covalent compounds. Solubility of covalent compounds. Now, covalent, these are also called molecular compounds. Just for differentiation, molecular compounds. All right. So for example, I give you this thing, CH3OH. Okay. And I give you C2H6. C2H6. And then I give you CH3COOH. Okay, tell whether they are soluble in water and tell whether they are soluble in oil. And then I also give you, let's say, NaCl. Okay, soluble in water is methanol. It is the first one. Soluble in water? The first one. Water and CH3OH. Okay, so you guys are not fair. Okay, so the way to do this is that, let me just remove this here. Soluble in water. What is water? H2O. And what are the properties of water? What kind of molecule is it? Polar, non-polar? Polar. So the solubility of the covalent compounds is based on the formula like what? Like dissolves like. Okay, like dissolves like. What does that mean? This means that the polar and polar are going to mix. So polar and polar mixes and non-polar and non-polar mixes. So polar and polar mix, right? And non-polar and non-polar mix. So, so those entities that are like polar will dissolve in water. Okay, so you have to identify whether the molecule is polar or not. Okay, so water is polar. So therefore, they are going to see the other entities, you will have to see if they are polar or non-polar. The second thing is, if you have, let's say, oil is non-polar. Okay, so the other entities you're going to see if they are non-polar or not. So now let's look at it. Methanol. So this is CH3OH. Is it polar or non-polar? What do you see here? See, okay, this OH, you see this OH right here? This alone, what is the speciality of oxygen? What is the speciality of oxygen? Oxygen is very electronegative. So because of oxygen, polarity always comes in a molecule. At least the bond will always be polar. So there is a polarity in this molecule. So this guy is going to be polar. So this is polar. So if this is polar, this will dissolve in water. So this will so polar and will dissolve in water. So I'm going to put it here. Soluble in water, yes. So like that, okay? What about C6H6? Non-polar. Remember, when there are lots of carbon-carbon or carbon-hydrogen bonds, they always make things non-polar. So when there is a non-polar here, non-polar, so is this going to dissolve in water? No. So this is a non-polar. This one is, so 1 second. So this is, yes, polar. So this is non-polar, and non-polar and polar do not mix. So this is going to be N. Okay, what about the CH3COOH? Yeah, remember oxygen. So this guy is again polarity here. So this is polar. So therefore it will dissolve in water. Yes. NaCl is ionic, and most of the ionic compounds, the rules are there. It's sodium, soluble in water. Yes. Okay. Now let's look at will CH3OH dissolve in water? In oil, sorry, in oil. Soluble in oil? Is it soluble in the first molecule, CH3OH? Soluble in oil? Oil is non-polar. So always remember that oil, anytime there is a oil, non-polar. Non-polar. Okay. So here you have non-polar. So soluble in oil, and no. The first one is no. The second one, C2H6, which is non-polar. Yes, because it is non-polar. CH3COOH, no. And NaCl ionic, never. No. Okay. So that's the main thing with the solubility of these ionic and covalent compounds. So look at also the thing, let's look at this since we are studying here. So things that you have to watch out for are the intermolecular spaces. So even though some of the species have been done in the previous chapters, but its chemistry is all comprehensive. It's all ongoing. Okay. So you will have to now make sure that you understand, the concept, whether they are generally coming from the previous lectures. We are building upon those concepts. It doesn't matter. So intermolecular forces, intermolecular. Okay, intermolecular forces. Okay. Now, what are the intermolecular forces? One is the dipole-dipole. right? In which you are going to look at the polarity in the molecules, whether the molecule is polar or not, whether the molecule is polar or whether the molecule is non-polar. Okay, so if there is a polarity, there will be dipole. Just keep that in mind. Okay, so you have to identify that, and dipole exists only in, so I'm going to just put this here, D and D. So that means dipole exists. It will be soluble in polar substances. So the next one is what? London dispersion. London dispersion forces are present in all molecules. So kind of that rules out when it comes to solubility. But the third one is the hydrogen bonding. So in hydrogen bonding, what happens? That hydrogen is attached to oxygen. This hydrogen is attached to nitrogen, and this hydrogen is attached to fluorine. Anytime you have this type of arrangement, where hydrogen is attached to this hydrogen is attached to these three elements, there is going to be hydrogen bonding. And that hydrogen bonding is also responsible for the solubility of molecular compounds. Okay, causes. So you have to check this hydrogen bonding between two different molecule. So it's not within the same molecule, it's between the molecules. So it's a network, okay? So that is intermolecular forces are also responsible for bonding. Oh, so responsible for solubility, sorry. Responsible for solubility. Okay, clear? So this is what we have. All right, next is the fourth. All right, next is we are going to look at balancing the molecular equations, molecular balancing. So identifying the products. So this is something you absolutely should know. Okay, identifying the products, then balance, then identify the solubility, and then identify the solubility, and then what else is there? The total ionic, and then net ionic, and then uh, total ionic, net ionic, and what are those called? Spectator ions. Thank you. Spectator ions. Okay. So these are the things. So then let's look at this scenario. Okay. So first of all, if I give you these, so let's say if you can do this, calcium nitrate, NIT, and I'm giving, I'm giving some difficult ones, calcium nitrate and sodium phosphate. First of all, write their formulas. So calcium nitrate, same thing, calcium, Ca, nitrate, NO3. Charges, calcium, which group? Group 2A, right? It's group 2A. And then group 2A is, that means charges +2. Nitrate is -1. And then sodium phosphate, Na +2, +1. And phosphate is PO4 -3. Crisscross. What do you get? This guy comes here and this one goes there. This one goes here and this one goes here. So now write the formula. So this becomes Ca brackets NO3 whole twice. Everybody understood how that formed? Because anytime more than +1 charge is carried over, the polyatomic ions is put in the parenthesis. Okay. Next is the sodium phosphate. Sodium phosphate is Na3PO4. Okay. PO4. Now let's identify the product. So at least this part is good. Now, outer, inner. Remember that calcium is going to connect with phosphate and sodium is going to connect with nitrate. Excellent. So now what will you write here? Right. So you are going to, let's identify the products here. So when calcium combines with phosphate, so calcium plus 2, and here you have now phosphate minus 3, right? And the other one is sodium, Na plus 1, and then you have the nitrate, NO3 minus 1. Okay, write down them as their like charges should be. Phosphate should have minus 3, nitrate should have minus 1, sodium should have plus 1, and calcium should have plus 3. Now what will you do? Crisscross. So as same story, this number comes here and this number goes there. Similarly, this number comes here and this number goes there. What do you get? Yeah, so you have here Ca 3 PO4 whole twice plus NaNO3. Okay, so this is you identify the products, right? In a molecular equation, you identify the products and then now you are going to balance it. So this was unbalanced at this point. So this is just unbalanced, but we identify the products only, unbalanced. And we identify the products only, So this is how you will do this. Okay, so that's one part. So we are looking at the products like this. Okay, part A. Next, let's do the balancing, part B. So now we have CaNO3 whole twice plus Na3PO4. And that gives you Ca3PO4 whole twice plus NaNO3. Now balancing. Now here's an interesting thing. When you balance, it's okay to not put charges. So let me write this in red. So when balancing, we can bring charges later. When balancing, it is okay to not put charges. Okay, so now you have Ca plus 2 and then nitrates. How many nitrates? Oh, I was okay. I'm a bit habit of putting charges. So there is one Ca, right? And how many nitrates? 2 nitrates, NO3. And then how many sodiums? 3 Na. And how many phosphate? 1 PO4. PO4 is 1 polyatomic ion. Then there are 3 calciums and there are 2 phosphates, right? 3 calciums and 2 phosphates. And then you have 1 sodium and you have 1 NO3. All right, this is what very basic. Now, what is not balanced? Everything, pretty much, right? So you can just say there are 3 calciums. So if you put 3 here, that means this times 3 and times 3. So this gives you 3 calciums and 6 nitrates. Yeah, 6 nitrates, NO3. Okay, so calciums are balanced. Now there are 6 nitrates on one side and there is only 1 nitrate on the other side. So if you put 6 here, that means 1 times 6, 1 times 6. So now how many sodiums there are? 6 sodium. And how many nitrates there are? 6 nitrates. All right. Right. Now sodiums and phosphate. How many sodiums? There are 6 on one side and 3. So if you put 2 here, so this becomes what? This becomes 6 sodiums and 2 phosphates. Yeah, PO4. Okay. So now check. There are 3 calciums, 6 nitrates, 6 nitrates, 2 phosphates, 2 phosphates, 6 sodiums and 6 sodiums. Got it? Yeah. All right. So that's one piece. Now we are going to look at the next thing is the charges. Now charge. So charge. So this was just a working to balance. So this is just all this is. So that's why I said it's okay when you're doing working. So this is just working done to show balancing. All right. Now put the charges. So C, ionize it. So now we have 3 calciums. The charge on calcium is +2. Oh, there's something else we didn't do. Sorry about that. Solubility. Yeah, solubility. So let's do this here. Calcium nitrate, soluble, insoluble? Soluble. Nitrates, all nitrates are soluble. Okay. Sodium phosphate, soluble. Okay. Then calcium phosphate, insoluble. And then sodium nitrate, soluble. Nitrate, sodium soluble. Okay. So now that means there will be 3 calciums, aqueous. Okay. And there is going to be 6 nitrates. So just copy, exact, just put charges then. So at least, you have this part covered. Next is you have 6 sodium and charge +1. And then you put aqueous. And you have next is the 2 phosphates, PO4 -3 aqueous. Okay. And then what do you have here next? Is the 3, so this guy, Ca3, PO4, hold twice will not. So this is because it's a solid, so it will remain as it is. But you will have 6 sodiums +1 charge, and then you have 6 nitrates -1 charge, and these are aqueous. And the other one is also aqueous. Okay. All right. Now you have this scenario where all right. Now you have where is the now? Yeah, the last is so this was a total ionic. Total ionic, you will write down like all the ions. And then D. And then the net ionic. So what is the net ionic? Net ionic is the ones that are showing the change of state. So you see there are 3 calcium ions +2 charge aqueous reacting with 2 phosphate ions, 2 phosphate, 2 PO4 -3 aqueous, and that gives you Ca3 brackets PO4 whole twice, and that is solid. Okay. And then what are the spectator ions? 6 sodiums. The ones that spectators are the ones that do not show the change of state. So we have sodium ion +1 charge aqueous, and then we have nitrate ion, NO3 -1 charge aqueous. But how many? There are 6 sodiums and 6 nitrates. Okay. So, a lot of it, you kind of know it, but I think it's just putting the charges or all the details that kind of sometimes creates like, confusion. But this is built upon that solubility and ionization, all those things. Okay. So we are going to cover only the big important pieces here. So some of the stuff you still have to go back and review. Okay, next, 5. Now I'm going to start off with the, let's do the reactions. Let's do some of the problems, problems that relate to reaction stoichiometry. Reaction stoichiometry, STOICHIOMETRY, reaction stoichiometry. So let's say here you have a reaction such as H2SO4, and this is reacting with KOH, and this is giving you K2SO4 plus H2O. So first of all, this is the acid. H2SO4 is the acid, which I'm going to say A, and KOH is the base, which I'm going to say B. All right. So this is a neutralization reaction. Neutralization. And neutralization reaction is where there is an acid and a base reacting to give salt and water. Okay. So now A and B. So let's say you are given, let us say you are given 5 molar KOH, and you use the volume, that's the molarity. So molarity is 5 molar and the volume is 25 milliliters you used. You have 10 milliliters of acid, find the molarity of the acid. Okay, so this type of question, right, where the acid and a base is given. So what will you do? What are the first step? The first step is to convert milliliters to liters, right? And what is the second step? The second step is to find the moles of the, if the base has a molarity and a volume given, then you find the moles of the base. Okay. So how do you do that? So this becomes NB. NB stands for the moles of the base is equal to molarity of the base multiplied by the volume in liters of the base. All right. So that's one thing. Next, once you find the moles of the base, then you should find the moles of the acid. And how you're going to do this? You are going to take this is the NB, the moles of the base, whatever moles of the base you found, multiply by the mole to mole ratio or the conversion factor from the reaction. So here you will see the acid will be on the top, whatever acid you're using, base is at the bottom, and this is from the reaction, the coefficient, whatever number is here, whatever number is here, okay? So this is going to give you the moles of the acid, okay? And this part, like I said, is coming from the balanced equation, BALANCED, balanced equation. All right? So it's very important to always check for balancing. So let's do this one first. We didn't even check for balancing this one. H2SO4 KOH. There are 2 potassiums there. So put 2 here. Okay, 2 potassiums. So water should be 2. So there are 4 waters, 4 hydrogens, 2 oxygens, 1 sulfate, and 2 potassiums. Balance. So it's basically 1:2 ratio, right? So this is that thing that is in the balanced equation, the number in front. After that, what will you do? After that, you're going to take the moles of the acid, right? And we need to find the molarity. Remember that the moles of the acid divided by the volume of the acid in liters, okay? And that is equal to the molarity of the acid. Okay? So these are the steps you are going to follow. Got it? Okay. So I'm going to write now. We need to move on because it's, so you guys should practice. But anyways, I'm giving you these questions so you can practice on your own, but we need to move on to the next one. That second one, because stoichiometry is a very important part, So one is this one is related to the reaction stoichiometry, related to the neutralization, and this is also called titration. This is like the procedure is titration. So if, you see the word titration, this is where, this is the steps, okay? All right, next, B. All right, next is reaction stoichiometry. But here, let's say, find the, so this one was find the molarity. So to just finish that, find the molarity, the top one. So if the question is saying find the molarity of acid or base, this is how you will do, okay? Now, the next one is another one. And if this one is about find the grams, so you just have to go a step further. Find the grams. Okay, find the grams of the reactant or the product, doesn't matter. When molarity and volume are given. Okay, of something are given. Okay, so let's look at this one now. Okay, let's say, for example, you are given, let's say, zinc, okay, as a solid reacting with HCl. Okay, HCl is aqueous. Okay, and this gives you this gives you ZnCl2 aqueous plus hydrogen as a gas. Okay. Okay, and so here we will balance it out, and this becomes 2 here. So here we are given, let us say, find the grams of the when the molarity and volume. So here, let's say you are given is the molarity of HCl. Let's say 5 ml, 5 molar, right? 5 molar is given. Let's do this. 5 molar is given, okay? And the volume is let's say 10 ml HCl. You are using 10 ml HCl. You are using. How many grams of zinc is used in this reaction? So in this case, the story is still the same. The story, same story. The story is, let me grab this first. So in this case, okay. Okay, so in this case, there are a few things. Same story, you are going to convert milliliters to liters, but here, because we need to find the grams, right? So keep this in mind that anytime the molarity and volume, so you need to recognize that this is the molarity and this is the volume, right? This is the volume. So the formula that is used to find the moles of any entity, moles is equal to molarity times volume. Okay, this is one thing. And then the second thing that is going to be needed, because we need to find the grams, is though we would need the molar mass. So put this information on one side. Here we would need zinc. Zinc, the molar mass is 63 grams per mole. And this thing you can get from the periodic table. All right. So somebody can check. Is it 63? Is it 63? Yes, okay. So you're going to do the same thing. Since 65? Okay, thank you. 65, okay. So here is the 65 grams per mole. Thank you. Okay, anyway, so here you have milliliters converting to liters, okay? Same story. Anytime volume is given, convert to liters. Next, find the moles. So in this case, we are looking at finds the moles of the acid. So here is find the moles of acid. Okay, so how? Molarity times volume is the base. Molarity times volume, you get the moles. Next is find the moles of the other entity, like the other reactant. So we have the moles of one. So now we need to find the moles of the other reactant, whichever reactant, is there. So in this case, it's zinc. So how is that going to, you're going to take the moles of the acid. Sorry, this is all acid. Okay, so this is again moles of the acid times the molarity of the acid times the volume in liter of the acid. This gives you the moles. Next, you're going to take the moles of the acid, multiply by the mole to mole ratio, where we are looking at whatever the reactant we are trying to find, right? You take that reactant, moles of that reactant over, the acid, the moles of the acid that we have. Okay, so acid moles at the bottom and the number of moles. So that obviously the coefficients, you have to look at that and it cancels out. And that gives you the moles of the other reactant that we are trying to find. In this case, zinc. So what is the last step? Now we got the moles and we need to convert to grams. So what are we going to do? Convert the moles to grams. What will you do? Convert the moles of whatever reactant is. R stands for reactant. R is reactant. Okay, and in this case, it is the zinc. Okay, and A stands for acid. Okay, and B stands for base. So, but in this case, there's no base, but just so you know. All right, so N, number of the moles of the reactant. Next is, we got the moles of the reactant, okay? Now you take the moles of the reactant, and convert it into the grams of the reactant. Okay, so what will you do here? You are going to take times molar mass of the reactant over 1 mole of the reactant. Okay, so here molar mass, this is the molar mass. Over 1 mole of the reactant. Okay, so number of moles times the molar mass. All right, so you guys, then this is going to give you the grams of the reactant. Okay, clear? Fine. Will you be able to do it? So you can do it 5 moles. So multiply 5 times 10, 50. No, 5 times, no, 10 ml becomes what? Let's do this in case. Let's just do this here. So let's do this. I've given you the strategy, but let's do this here. First is 10 ml times 1 liter over 1000 milliliters. So this gives you 0.010 liters. Second step is the number of moles of HCl is equal to molarity of HCl times the volume in liters of HCl. And here what you have molarity is 5 m times 0.010 liters. So what do you get here? 0.05 moles. These are the moles of HCl. Now we need to find the moles of zinc. This is zinc, right? Zinc. We need to find the moles of zinc. So what will we do? We are going to take the moles of HCl, which is 0.050 moles of HCl times what? Mole to mole ratio, balanced equation. So it's, what is that ratio? Yeah. So there's 1 mole of zinc every 2 moles of HCl. That is the balanced equation. So from the balanced equation, what do you get? Yeah. 0.050 divide by like 2. What do you get? 25 moles. Okay. And these are the moles of zinc. After that, convert the moles of zinc to 2 grams of zinc, right? And so here we have 0.025 moles of zinc multiply by what? Yeah, very good. 65 grams of zinc, because that is the molar mass over 1 mole of zinc. So do this. What do you get? 65 point times 0.025. How much? 1.65? 625? 1.625 grams of zinc. So if in this reaction, this is how you determine if you have a certain amount of HCl and you want to produce zinc chloride. So you just kind of figure out like how much of the zinc you would need if you use those specifications. Okay, guys. So that's one thing. So reaction stoichiometry, 1, 2, find the grams. And then the other types of reactions are, the other type of problems are the ones that are based on the concentrations. But this one you must get these nailed out, reaction stoichiometry. So 6. Now the rest is related to the concentrations. Okay, concentration problems. Concentrations. So okay. concentration problems. Now, number one here. Let's say there is 25% 25% rubbing alcohol. Okay, 25% rubbing alcohol. Okay. And you have a solution. Oh, just give me 1 minute. And you have so you have a solution that is, let's say, 500 milliliters. Okay. Find in this solution how much rubbing alcohol is there. Yeah, rubbing alcohol is there. Okay, so how will you do this one? What does 25% mean to you? Say that again. Yeah. So here it means 25%, it means that 25 rubbing alcohol, so concentration ml, because we are looking at mass ml. So here you have 25 milliliters of rubbing alcohol is present in 100 milliliters of solution. This is what it means. Okay. And this thing can be made into 25 milliliters over 100 milliliters of solution. 25% rubbing alcohol in ALC is alcohol over 100 milliliters of solution, or 100 milliliters of solution, 100 milliliters of solution over 25 milliliters of rubbing alcohol. Okay, so these are the way you do it. Next thing is, so here you are given 500 milliliters of solution. If you take out 500 milliliters of this solution, then, yeah, is there someone, you have a question? Okay, so 500 milliliters of the solution will contain how much alcohol? So you take 5 milliliters, 500 milliliters of the solution times that conversion factor, that cancels out. Very good. So 100 ml, so rubbing alcohol, 25 ml. We want to find out how much of the 25 ml is present in 500. So 25 ml rubbing alcohol is present in 100 ml solution, right? So 500. So what is the answer here? Very good. So in this case, it becomes 125 milliliters of rubbing alcohol. Clear? So this type of question. Okay. Yeah, see, the other ones are easy. It's just a reaction stoichiometry, and the other one are like more detail oriented. Okay, let's look at the other ones, the simple ones. Now, okay. So if you are given, let's say, 5% mass by volume salt solution, NaCl solution, okay? You are given, this is given to you, right? And you are mass by volume salt solution. And so the question is, how many grams of NaCl, right? How many grams of NaCl needed to prepare are needed to prepare 200 ml of 5% mass by volume salt solution, NaCl solution. Okay, so this is the question. All right. So this is the question. But you want to prepare. So how many grams of NaCl are needed to prepare 200 milliliters of 5% mass by volume NaCl solution? Got it? So first of all, so same story. 5% mass by volume would mean what? 5 grams of NaCl is present in, excellent, 100 milliliters of solution. That is the volume. Okay, right? And the other conversion factor is 100 milliliters of the solution over 5 grams, over 5 grams of NaCl, right? So this means that this whole thing, let me write this down. This means that 5 grams NaCl is present in 100 milliliters of solution. Okay, so this is what it means. Okay, all right. Now what will you do here? So same, how many grams of NaCl are needed to prepare? So we are going to first find out. So the same way you will do, 200 milliliters will contain how many grams of 5 ml. So you are going to here find how many grams of NaCl are in 200 milliliters, right? 200 milliliters of 5% mass by volume salt solution. So you see that so you're not doing any moles or anything in these type of problems. We are just looking at, like, volume. And so this thing, the question is just worded a little bit differently. This wording and this wording they still mean the same. So you will set it up like this. So you're going to write down here 200 milliliters of the solution, right? Multiply by, we need to find the grams, right? So 5 grams. Very good. Yeah, over 100 milliliters of the solution. So that cancels out and you get the answer. Okay, so this type of question can be asked. So what is the answer here, by the way? 10 grams. Okay, so like that. Okay. Okay, now another one is, now be careful, like read carefully. That's the mistake students make, is like, okay, what is this question? What is Okay. Next is like another question is how many grams of, let's say, glucose, glucose, how many grams of glucose are needed to prepare, oh, sorry, wait a minute. It's not, we already did that. Mass by mass percent, okay? Let's say mass, calculate mass by mass percent. How much is that? When you have 10 grams of sugar, glucose, in 100 grams of water. Okay, what is the mass by mass? So pay attention to this. Anytime there is something like this 100 grams of water, what will you do? This is the solvent. Okay, this is not the solution. This is the solvent, and this is the solute. Okay, this guy is the solute. So what will you do here? You are going to take the 10 grams of glucose and you will add plus 100 grams of water. So only then you will have the solution. So 110 grams is the mass of the solution. Okay, so what will you do here now? 10 grams of glucose. And what will you do next? Divide by 110 grams of solution, right? And you're going to multiply that by 100%. So what do you get here? What do you get? 9.09% mass by mass percent glucose solution. This is how we say it. Glucose solution. Clear? Clear? Okay, so these type of question. And another type of question can be asked is, so just go ahead, go home and just do more of these. But another type of question is find the molarity. Find the molarity. So you are given, let's say, Al2SO4 whole thrice, okay? And you are given this 5 grams, okay? And you are making a volume of 750 milliliters, right? So what is the molarity? So first thing here, you are going to find the molar mass. Molar mass of Al2SO4 whole thrice. So it's like it's always chemistry is built upon. So you need to look at 2 aluminums. There are 3 sulfurs. There are 12 oxygens. All right. And what do you put here? 2 aluminums, 27, sulfurs, 32, and oxygens, 16. So what do you get here? Aluminum times 27. So whatever you get here, that's the molar mass, right? And that is going to be grams per mole. Grams per mole. Okay, that's the molar mass. Next is molarity is equal to moles over liter, right? Volume in liter. But we are given 5 grams of Al2SO4 whole thrice, right? 5 grams. You convert it into the moles. So 1 mole of Al2SO4 whole thrice, right? Divide by the molar mass. Molar mass is always M, like a different type of M, because that molarity is different. So just look at it. So molar mass. So like that. Okay. So molar mass of, so whatever you get here, that's going to give you the moles of, and then you put the moles. Put the moles. So molarity M is equal to the moles of Al2SO4 whole thrice. Divide that by the volume in liters you just now calculated. Volume in liter. And that will give you the molarity. Okay. So that many questions. Okay. Next question is about the Yeah. Okay, next is the find the molarity. So this we have done. Okay, the next part is, so these are the concentration problems. Okay, next is this problems you guys already should know. If you are given the, here you can say find what is the, find the final temperature. Yeah, find the final freezing point or boiling point, right, of a solution. So just make sure a few things here. You will be given, so use this formula, delta T B or delta T F, okay, is equal to I times KB KF times M dash. So M dash is the moles of the solute, okay, moles of the solute over the kilograms of the solvent. So this part you should get on one side. KB, KF values will be given to you. KF will be given. So just use those numbers. Okay. Next, the tricky part is the I. I for the ionic compounds is the number of ions. So if it's an ionic compound, you should write down the total number of ions, right? So if, for example, NaCl will give you 2, the value of I is equal to 2, right? If you have MgCl2, then it's 3 ions. So it's 3 ions, the value of I is 3, like that, okay? So, but for the I is equal to, for covalent, which have a lot of, like, let's say carbon-carbon, carbon-hydrogen, like those type of organic compounds, the value of I is equal to 1. So just pay attention to that, okay? And then the last thing is what is the value of the final temperature? So this is delta TB or F, right? Whatever we are doing is T final. T final we are trying to find, right? Minus the T initial. And what is the T initial? T initial. So remember that the freezing point for pure water is equal to 0 degrees Celsius. So this is the T initial. And the boiling point of water is 100 degrees Celsius. That is the T final. That is T final. No. Yeah, 100 degrees. So that also is T initial, not the final. T initial. That also will be T initial. Okay. But final we have to find out. So we are finding the change. This is the change in boiling point or melting point or freezing point. Okay. So question is there. All these questions we are discussing here are there. Okay, guys. All right. Next is, let's continue a little bit more. Next is this is a big chapter. Okay, let's see. 1 second. I think 15 more minutes I need to finish this. Okay. Okay, now some of the other theory-based questions. Theory. Okay. So theory. So first of all, what is solvation? What do you mean by solvation? So know the meaning of solvation. Okay. Solvation of ions. What does it mean? Okay. According to the Henry's law, second thing is, what is the relationship? So this I'm going to, you guys have to review this in your, look at the lecture notes. We covered this. Now I can't go on discussing theory here, okay? Lecture notes. Okay, next is, what happens to the solubility of, so we covered the solubility of the solids, right, and liquids, but solubility of gases. What happens to the solubility of gases? When the temperature increases and when the pressure increases, what happens to the solubility? Yeah. Solubility of the gases decreases when the temperature increases. Okay. So keep that one thing in mind. The other one is opposite. So when the temperature decreases, the solubility increases. So always in cold waters, cold liquids, the gases remain soluble. Pressure, when you increase the pressure, the solubility goes up. If we decrease the pressure, the solubility goes, decrease the pressure, yeah, solubility goes down. For gases. Oh, sorry. Yeah, it's the gases, okay? This one, yeah, good. Okay. Okay, then the concept of electrolytes and non-electrolytes. So this one we did the lab, right? So electrolytes. What are the electrolytes and non-electrolytes? Electrolyte. So remember, it is tied up to the solubility. This also is tied up to the solubility and ionic character, right? Solubility. So first of all, solubility of ions. So if the ions are soluble, then yeah, they are going to be, they will conduct electricity. But if it is insoluble, so these will be, so in other words, they will be electrolytes. This would be electrolytes if the ions are soluble. But if they are insoluble, non-electrolytes, insoluble, so they are non. So how do I write this? So this is electrolytes and this is non-electrolytes. Okay. Okay. So they are not. So let me remove that. All right. So next is the weak electrolytes. What's the deal with weak electrolytes? Partially. They are partially soluble. And so partially soluble means partially ionizing. Okay. Not completely ionizing. So they will be electrolytes, but weak electrolytes. So know that. Okay. Weak electrolytes. So weak electrolytes, what will you see in the weak electrolytes? Okay, yeah, you will see like equilibrium type of thing. So the reaction, so A is breaking up into like, sorry, AB is breaking up into A and B. So like that, like something like that. Okay, so this is one theory based. Rest is the so 100%. So this means electrolytes also are 100% dissociation, right? Ionization. So 100% dissociation, strong, will create strong electrolytes. And so partially ionizing is less than 100% ionization. Okay. And non-electrolytes is no ionization, will not ionize. Things do not ionize completely. And they are insoluble in water, okay? Okay, third thing, like another thing is the boiling points. Tell me the boiling point and the freezing point of water, how is it affected? So you have here the boiling point of water, okay? At sea level, right? Not like, let's say on plains, on plains where the atmospheric pressure is 1 atm. So the water boils, water boiling point is equal to 100 degrees Celsius. But if it is on the hills, if the water is on the hills, then at like ATM, which is less than 1 ATM. So it's lower than 1 ATM. Temperature is, the pressure is lower. So the water is going to boil fast. So the boiling point decreases. Boiling point goes down. Boiling point is less than 100. Things boil faster in low pressure. So this is a low pressure environment. Okay. But if it is on the sea, like on the beaches, on the seaside, wherever there is beaches, more atmosphere, like heavier atmosphere. So what happens at a higher than 1 ATM, right? High pressure. So in that case, the water is going to boil when? Higher than 100. It's going to take water very high to boil, okay? Okay, next. So when we talk about boiling, we are talking about boiling here. So what is a vapor pressure? You should know what is vapor pressure. What is a vapor pressure? The pressure of the vapors, right, that accumulate over the surface of the water. So as the vapor pressure, so for the pure liquids, so pure liquids, pure like pure solvents, I mean, pure solvents, it's like water, the vapor pressure. Okay, when for the solutions, the vapor pressure is lowered, gets lowered, okay? Yeah, so the vapor pressure gets lowered, but this is the pressure that is present on the liquids, on the surface of the liquid. So here is this, you must have seen also water. So here's the water, and this is the liquid, and this is the liquid state. And here, when you're boiling it, you will see the vapors accumulating. So vapors of this liquid, they are on the surface, on the top surface of the liquids. Okay, clear? All right. The next is, the rest of it is the gas laws. And then the other pieces, the gas laws and what time is it right now? What do you say? Should we continue with the gases or let go? Just do a little bit. Let's do a few. One. There's a lot in this chapter. Okay, number two. Huh? Yeah, I know. There was a lot. Yeah. Okay, gases. Okay, gases. So gases, guys, gases. Okay. So we'd already discussed a lot about the gases. So I'm going to just keep it here. Boyle's law, Boyle's. Generally, students do good. Like we said, Boyle's law is P1, V1 is equal to P2, V2. So we already gave you like the transformations, right? Charge is volume 1 V1 over T1 is equal to V2 over T2, right? Boyle's Charles, and then Gay-Lussac. Gay-Lussac is P1 over T1 is equal to P2 over T2, right? And then the other one is the combined. The combined is P1 V1 over T1 is equal to P2 V2 over T2. Okay, so these things. Then comes the ideal, Avogadro's. Avogadro's is Avogadro. V1 over N1 is equal to V2 over N2. Okay, next is the ideal. So ideal is PV is equal to nRT, right? Now STP, concept of STP. STP, if the question is saying an STP, temperature given 273. Pressure, 1 atm, right? Moles is 1 mole, right? And temperature, no, sorry, volume is 22.4 liters. So next is so these things, and then Dalton's law. Dalton's law is total pressure, P total, is equal to P1 plus P2 plus P3. Now, you should know the conversions. These are going to come. Very important. Conversions. Okay, conversions. What are the conversions? The conversions is 1 atm is equal to 760 millimeters of mercury. Most of the time, I only give, these simple conversions. Okay, so you know the conversion factors from here. Another conversion is degrees Celsius plus 273, and that gives you the answer in Kelvin. Sorry, not degree, but Kelvin. Okay, this is one piece. And conversions, what else? Yeah, and then just make sure the value of R. If the value of R is 0.08206 liters atmosphere per mole K, right? And the other value of R is 62.4 millimeters of mercury times L over mole K. Okay, so we see here that these, so if pressure is in atm, then you use that value of R. If pressure is in millimeters of mercury, then you're going to use that value of R. Okay, so that's one piece. Okay, so let's do this. Let's do one question here, 1 or 2 questions. A. Okay, let's see. A tank contains like 305 millimeters of mercury. Contains, let's say, helium. Helium is 305 millimeters of mercury. Helium, 305 millimeters of mercury, right? Xenon is 2 atm. Okay, and ammonia is 620 torr. Okay, 620 torr. So find the total pressure. Find the total pressure. These are the pressures. Pressures of helium, pressure of xenon, and pressure of ammonia. Find the total pressure. So you are always going to write the formula. So P total is equal to pressure of xenon plus pressure of helium plus the pressure of ammonia. Okay, but the problem here is, you see this, make sure that these are the same. So you must have, and if the question is saying find the answer P total in millimeters of mercury, so you have to change this 2 millimeters of mercury and this 2 millimeters of mercury. So first do that. So 2 atm. So we have 2 atm pressure of xenon. Xenon is 2 atm. Okay, so we need to convert it into millimeters of mercury because they want the answer in millimeters of mercury. So 2 atm multiply by 760 millimeters of mercury over 1 atm. 1 atm. Okay, so what do you get here? 1520 millimeters of mercury. So very important that you write the units. Okay. So that was one thing. The next one is P, NH3. And we convert it into, so here you have 620 torr, 620 torr times millimeters of mercury. Remember, they are the same, 760 millimeters of mercury and 760 torr is the same. 760 millimeters of mercury is equal to 760 torr, or 1 torr is equal to 1 millimeter of mercury. It's the same. They are the same units. So let's do this. Put it here. One is, so maybe you can make a note here that 760 torr is equal to 1 atm. And so 760 torr and 760 millimeters of mercury are the same. Okay. Or 1 torr is equal to 1 atm, 1 millimeters of mercury. Okay. So here, what will you do? Here, you're going to put 1 millimeters of mercury over 1 torr, 1 torr. And what do you get here? You get 620 millimeters of mercury. Okay, and the rest is just add. So PXE plus PNH3 plus what's the other one? HEXE and NH3, HE. So HE was 305 millimeters of mercury, right? And NH3 is 620, no, sorry. Yeah, 620, NH3, 620 millimeters of mercury. And XE is 1520 millimeters of mercury. Okay, so when you add whatever answer you get, that is going to be the P total. The 3, 4, 2445 millimeters of mercury. Okay, so that's the type, right? And should we do more or what? No, okay. And then the last one is easy. Like this one, just make sure that you look at these, this one. So the reactions, the reaction, it will cover, but I haven't covered that in this. So CH on the reactions, reaction equilibrium, reaction rates. This will be on the test, but you do on your own, and equilibrium. All right. All right. All the best, but the solutions one was a hard one. Please review all lectures. All lecture notes. All right. And all the best. All right. Okay, stop recording now.